Okay, let us do this question that was given. In this question, n mole of N2 and 0.045 moles of argon are enclosed in a vessel of capacity 2 liters at 1 atmosphere pressure and 27 degrees centigrade temperature. Find n value. So before starting this question, let me introduce you three gas laws. Three gas laws are, first one is Boyle's law. Boyle's law states that whenever I take a system like this and I take a piston like this and I put a gas, some kind of gas here. When I increase the pressure over this gas, what will happen? When I push the piston down, the volume of this container or the gas will decrease. So at a constant pressure, I can say pressure is inversely proportional to volume. This was given by Boyle's law at constant temperature. Then we have got another law that is called as Charles' law. Charles' law states that volume is directly proportional to temperature. Temperature must be taken in kelvins only. Volume is directly proportional to temperature at a constant pressure. So if at all I take pressure constant and if I increase the temperature, the volume of the gas will also increase. Then comes Avogadro's law. Avogadro's law states that volume of any gas is directly proportional to number of moles. Volume of any gas is directly proportional to number of moles. So if at all more number of moles are there, it will occupy more volume. Okay, that is what Avogadro's law means. Next, the fourth one is Gay-Lussac's law. This law states that pressure is directly proportional to temperature. More pressure, more would be the temperature. Combining all these gas laws, we give an equation called as ideal gas equation, which states that PV is equals to nRT. Okay, this is what we are going to do. PV is equals to nRT. Pressure is inversely proportional to volume. Pressure is directly proportional to temperature. So we have combined all these gas equations and we have given this ideal gas equation, which is PV is equals to, or I can say PV is directly proportional to N into T and R is nothing but my gas constant. So PV is equals to nRT. R have got multiple values. If at all we take pressure in atmosphere and volume in liters, we are going to use 0.0821. If at all we take this in joules, then the R value would be 8.314 joules. If at all we take this in calories, R value would be 2 calories. In this, he has given you the R value as 0.0821, which we are going to use. Okay, fine. Now let us come to the question. We have understood the gas equation, that is ideal gas equation, that is PV is equals to nRT. Okay, let us take the same equation. PV is equals to pressure into volume is equals to number of moles into gas constant into temperature. Now, what is the pressure? Pressure is 1 atmosphere. Volume is 2 liters. Number of moles, we know that nitrogen ka moles also there and argon's moles also there. N plus 0.05. That are the total number of moles into gas constant. So N plus 0.05 into gas constant R, which is 0.0821 into temperature, which is how much? Temperature is 27 degrees centigrade, which we have to take in kelvins, which is 300 kelvins. So this would be 2 is equals to N plus, I can write it as 5 by 100. 0.0821, we can write it as 1 by 12. So if we write 1 by 12, the calculations would be easier. So whenever you get 0.0821, please write it as 1 by 12 into 300. Okay. So if I do this to 6 to 150s, 6 ones, 6 twos are 12, 3 zeros, 6 5, 2 ones, 2 13s. So n plus 5 by 100 is equals to 1 by 13. So n is equals to 1 by 13 minus 5 by 100. How much is this is going to be? 5 by 100 is 1 by 20. So if I take 260 20 minus 13, which is 7. 20 minus 13 is 7 upon 260. 7 upon 260 would be, how much that would be? 7 divided by 260. That's going to give me 0.0269. This is equals to how much? 0.0269. The nearest answer would be 0.03. That is C, option C. Hope you understood the question.